Good morning, sir.
A very good morning, Mr. Shafkat. So we're going to start at 11.
Yeah. Okay, fine. Thank you.
Uh,
And there are some echo, sir. I
is
I
it
think
so?
yes. I think you were speaking on some empty room, so there are some echo. The voice is a little bit high and hitting my ear itself. Okay, maybe my headphone is
Okay.
also, but yeah.
Okay, we'll try to resolve it.
Is my voice clear?
Yeah,
Okay.
absolutely.
Okay. Thank you.
Good morning and welcome to the third day of the 1 week faculty development program on artificial intelligence in advanced machine learning and cloud computing, AIAMLCC 2023, which is organized by the Department of Computer Science and Engineering of the Institute of Technology, held from 10th to 14th July 2023. So today we have on our panel Mr. Subro Sharkar, Principal Consultant, Cloud Tech Mahindra. So he'll be delivering a lecture on cloud migration and automation. Let me have a brief introduction of Mr. Sarkar. He's having 18 years of work experience with result-driven client relationship and passionate for growing business, known for demonstrating outstanding management, strategic planning, organizational development, and decision-making skills in high-pressure, high-availability environments. He has profound understanding of infrastructure technologies and software development methodologies. So over to you, Mr. Sarkar. So we can begin. Uh, I think you're not audible, actually.
Namaskar, sir. Thank you. Is it audible now?
Yeah, it's audible now.
Namaskar.
Yes, sir.
Yeah,
Yes, sir. It is audible.
Okay. Thank you. It's a pleasure to talking with you, all of you, and all the teachers who are in this discussion. And I'm trying to elaborate my sessions in such a way that whatever my experience I have in the industry, to share the knowledge and how it can be useful for that your teaching purpose that I will try to convey in this session. And before starting point of sight, I have some couple of years experience in the teaching profession. So almost 19 years I'm in IT industry. So 4 years I spent in teaching industry also. So I know that how much what is the gap on that what we are learning day by day and what we are currently delivering on the industry part of side. So as we know that the cloud is a big thing. It's a almost 12 and 15 years old things we are discussing. When it was started, it was actually started on the basis of that infrastructure provisioning, where we can do the start and deployment our applications. But slowly there are a lot of organizations that provider came in that throughout the world providing that cloud services, and that data center in multiple regions, multiple countries, multiple cities, so that it can be very near to the application streams and user streams. And mostly it's very helpful because what happened whenever this application is being accessible when internet is very much fast. Okay, I'm not talking about current situation. When it was started that time, no one thought it will be so big, because cloud being accessed over the internet, and internet day by day it's increasing. And you know that 5G, 6G, there are 6G already discussion has already started. So in future that cloud would be robustly work for that each and every service. So nowadays we are working on the AIML, because this AIML service is being exposed by the cloud service itself. So what I'll try to do that explaining that what do you mean by cloud, why we need the cloud, why you have to move to the cloud, and some of that my earlier experience on that cloud migrations, some architectural design. And I'll try to do some hands-on, but it's a robust thing. Okay, every day we are learning, because each and every solution has some challenges to implement in the cloud. Because whenever we are talking about the cloud, it's always in security is the high risk, because we are working in the private cloud. Okay? So sorry, public cloud. So that's been the security is the major concern. So when we are going to implement something for any organization, any application, so all need to be private in such a way that how we are converting this public's cloud and secure our application such that we can implement it at security part of side. Okay, let me share my screen first. Skip. I think I don't have the sharing, right? Okay. Yeah.
Sir, you can share. You
Yeah.
can share. No issue.
Is it?
Yes,
Yeah.
yes.
Okay. Oh, fine. That's good. Let me make it in. Okay, so I'll try to cover these things. It's a very small time because cloud is vast. Even we're learning each and every day, and there are a lot of things in the clouds area, and all that applications which we are building in mobile software, and we need CRM application. Everything is moving to the cloud now. So it's a vast, and it's a hot cake. You can say that if the people has a good knowledge on that clouds services, they are being hired from multiple big organizations, and they can switch one organization to another organizations that high salary. So this is very much high skill and popular to the industry nowadays. Okay, so I'll try to go through that some of that things, terminologies which we are using in the cloud, because I don't know the people who are working in working the IT industry. Might all people are not working, but now as we are moving to the cloud, so people are learning this cloud thing. But we have to jump to the cloud area. We have to know the terminologies which are being used for the cloud. And as you are teachers who are mostly mostly working on that the core competence area, because that is the actually you can say that is the main area where we should concentrate fast, because if you don't know that the core IT part, then we're not able to deliver or build the cloud services. So that's anyhow very much required. But I think there are some knowledge in the cloud areas very much required. So that's why I'm starting on that, some of the basic understanding and terminology. So I'll go through the something that agenda why we are going to cloud. There are some of that called SaaS, PaaS, and Isaac. Then what do you mean by that? Greenfield, brownfield migration, cloud ready, and what is cloud native? What would be the cloud governance model? What is the Haldia analysis? Some of the sample design I will go through, and how we can start for the students, so that in some major service provider like AWS, GCP, and Azure. I'll try to do that some hands-on, but if I not time not permits, then you can contact me offline. I can give you some of that steps. How can we start that? And then there are some estimation model. Whenever we are talking about the cloud movement, there are some lot of activity to be managed as a movement point of sight. So some project plan is there, what are the challenge analysis which we can try to cover. But major things is that, okay, how we are going to start in the cloud area, and why I'm talking about these points, that's PM role and checklist, estimation model, sample project plan, challenges and lesson learned. Why these are very much crucial for our cloud IT industry, because ultimately the end service which we are providing, that is to the end user, right? Like the people who are using these services, like we are using the mobile services, like we are using that State Bank mobile software, mobile app, right? We are also using that internet banking. So, but we are least bothered. This entire application is running on the cloud, or it is running on the on-prem or some laptop or desktop. We are least bothered because we are the end user. So whenever we are planning to move to the cloud, obviously that the organization like SBI itself, they will ask that, okay, I am going to get that putting a lot of money to move our entire application from on-prem to the cloud. Why should we go in the cloud? So that's why we have to know that why cloud, because the application is running fine, right? You have an application which has a banking application. Now we are saying that this is working fine. Then why we should go to the cloud? So that advantage I am to try to explain that why we have cloud. So these are that main advantage. Obviously, whenever we are talking about the cloud advantage and disadvantage, the advantage, there are a lot of disadvantage also. Okay, but still the advantages are so high such that we need to find out that mitigation plan of the disadvantage so that we can leverage that all the advantage of the cloud. Yeah, I don't know that how people are understand these terminologies, but let me quickly go through that some of the terminology when we are talking of the cloud. And sorry, I'm just moving to that in that normal mode. And I'm love to take that any questions. If you have any question, you just interrupt in between the discussions, and you can ask me the question. I try to explain to you guys on that my questions. Okay, on my presentations. So first thing, what are the advantage? Okay. Advantage is the scalability. Scalability means it's a elastic concept is there. Suppose your application is running on that one infrastructure, like if you have a small bank, say Bandhan Bank, nowadays it's growing very fast, but when they have started their banking system, they never thought their number of customer, number of transactions might be increased. Okay. So what happened? They have started their entire applications with that on-premise location, mostly on say West Bengal, Bihar, and Odisha, somewhere else, right? But they have some data center. They have direct connectivity with over that satellite connection point of sight. But what happened if as the bank is doing very good, so they need more capacity of that servers, which is very time consuming, because if we are talking about that increasing the capacity of your data center, you need to install new hardware, you need to install that network, you need to implement the connectivity, software need to be reconfigured. So that is a very challenging. Okay, challenging means this always any new scalable new things need to be installed. Like you guys very much aware about that. Suppose if you have a number of students 500 people, now you have an infrastructure and you have a lab where you are doing your entire student are doing the lab activity on from your college. So what happens is certainly if this college is doing good and a lot of new good students are coming to college, it's 500 become 5,000. So it's very difficult to accommodate these people, all the students in the same class and same lab, right? You are not able to provide the infrastructure to such that they can work on the desktop. So the cloud is that feasibility within the fraction of time, it can be increased. Okay, with that without disturbing your existing application. That's mean there is no intervention on that network. There is no problem on your infrastructure. The existing application will be run. Okay? And this scalability is being achieved by multiple ways. Okay, you have servers, you have Kubernetes cluster, you have storage, you have network. So all the things actually, whenever your application is running, the application needs server, the application needs memory, application needs your storage. Okay, so all the things which we were talking, like if you want to, for example, in your laptop, your desktop, you are working and you observe, okay, you are running some video games and it's out of memory, you are not able to run the video game. So what will happen? So sometimes that IT engineers, they are saying that, okay, you have to increase the memory, right? So how we are going to do that? So we need to shut down, okay, and open the laptop and install the new RAM or cache memory to be increased, okay, partition to be done. Like a lot of activity need to be done. But in cloud, we have everything is a virtual things, virtual cloud. So whenever is required in the virtual server is required, capacity can be horizontally increased, and that server can be storage can be increased, so there could be no disturbance. So that is called the scalability, and it's a vast area. So it's not scalability I'm talking about only that infrastructure. There are application scalability as concept is there, but it's a high level of discussion is required if we have to know that how to make the application scalability from that functional point of sight. Cost saving. Okay, now cost saving is a some different ways coming. Okay, what happened every 5-6 years, if you observe, there are data centers. There are a lot of data centers being used and the hardware being old, right? For example, even for we are using laptop mostly in that when we are student and where we are doing teaching portion, mostly we are not working with that big hardwares where that big applications are running, because we at least bother about this because our entire study is based on that some of that desktop and maximum some LAN connectivity is required on the, some server where we can store some data like that. Okay, so but what happened every 4-5 years you observe that your laptop is not working properly, your desktop is not working properly. This is slow day by day. It may be the hardware end of life cycle, or it might be that the software which we are running on that laptop or desktop that is not supporting that current infrastructure. So what happened? We have to buy a new laptop. We have to increase the storage, or we have to increase the memory. Okay? Or what we are replacing the entire laptop with that latest versions. Okay, it's a overall cost involved. And what happened? You need to install a lot of software also. Okay, for that, because there are a lot of change happening in the meantime, and if your application is running on that your desktop, that need to be changed again and reinstall that also. So cost savings means that instead of putting in new hardware or new purchasing new hardware servers on the data centers or laptop, I'm talking about the laptop for our school and college like that. Instead of that, okay, it's a very simple thing that okay, we can directly purchase from the cloud itself, but we might not require every time the high capacity. Why we are saying the cost saving? Suppose you have taken that high configurations laptop, but you need to execute some of the processes. Okay? It's happening in that mostly in the. If I'm trying to explain you that bank industry. Okay? In bank, what happened every month, and if you observe, the bank of people are very busy on the end of the month and starting of the first week. Okay? They're busy, and lot of activities happening because that time interest calculation, all transaction trading and verifications, everything is happening and everything is over that computer. So what happens is million of customers are there, and that verification is in month-end activities happening on that servers. But over the month, we may not have that huge capacity is required that server, right? So, but as we have to support the month-end activity, if we are using that data center servers, we have to keep that high configuration servers to be ready such that the month-end activity is required. Whereas rest of that 20 or 25 days, we are not using the high capacity. If you see the memory utilization, the CPU utilizations, disk utilization, it might be 20 to 25%, but whenever we are reaching to that month end, that time it's maybe 90-95% is reaching, or sometimes it's increased more than that. So we have to install more server. Like even for during puja vacations, puja time, right? We are purchasing a lot of things from that online stores like Amazon, Flipkart, okay, and that the transaction is being increased rapidly. Transaction being increased rapidly during specific term, but rest of the times it's not being used so much. So in that case, what will happen? Even for whole year, maybe it's required for high capacity is required, but rest of the time you don't need the high capacity. But to supporting that that 12 and 15 hours, or 15 days, we have to keep our servers or infrastructure capacity in place such that there is no disturbance to the end user. So what happened in cloud? They are providing whenever you want that high capacity, you take the high capacity, execute and release it. So elastic things, the scalability is mapping with the cost savings, right? Whenever is applications being need high capacity, it's automatically increase, and when it is not required, it automatically increase. So there are some node pool concept is there. There is a Kubernetes cluster is there. Auto scaling concept is there in cloud. So whenever there are high traffic, automatically the number of servers will increase, a number of capacity will increase, and serve that all the services to increase. Okay. Now, next is the accessibility. Okay, now cloud being providing the service over that internet, and as of now, we know that 5G, 6G already started. That these people are that mobile company, they have started that designing or implementing 6G already. China and Japan already started the 6G thing, right? So that's mean that the high internet bandwidth won't be available. So that's why the accessibility to the cloud is no more challenge nowadays. So whenever you are going, you can access your servers, you can modify your application without downtime, and because you have a high bandwidth connectivity. So accessibility point of the managing the applications is very much easy. Instead of going to the data center, you can directly working on that cloud from any location. Another is disaster recovery. Why disaster recovery? It's a very vital. Okay, and this terminology is very much popular in IT industry. Whenever we are implementing any applications, we have to think a couple of words like what is your disaster plan? What is your recovery plan? So in any organization, like application which is running in your data center, what will happen if there is a flood, if there is a natural disaster, if it's a power failure? Okay, because something will happen, an entire data center being shut down. Okay, it's underwater, or then entire application is not available. So that's why you have to do that disaster recovery plan. Even for on-prem data centers also, we are keeping the disaster recovery, right? On-prem data center, your application, suppose it's a banking application. So for banking application, they have a data center, say they have a data center in Mumbai, they have a data center in Bangalore, they have a data center in Pune. Okay, and all are synchronized. So all the data which we are running from any one of the location, all will be synchronized. Okay, and which we are learning from the database management system, the distributed database management system, network management system, these are the core things. So disaster recovery is always implemented for on-prem applications also, where that data center is located in distributed location throughout the country and throughout the different. But what will happen? Most of the times we are not using that disaster locations. Like you have your application is running on one data center, and that is entire data center we are just using Mumbai data center, for example, right? Now, whereas we have an entire configuration which supporting by Mumbai data center, that entire data center, the same configuration is available in Kolkata also, but that is not being used because if disaster happened, then it would be used. Okay, so that's mean cost is so high in the on-prem, okay. But still we have to keep the disaster recovery, and we have to make sure the disaster platform is working properly. So that's why there is a concept of disaster failure. Okay, disaster failure test, failover testing. Failover testing, what the failover testing? We don't know what is the natural disaster will happen, but how we are going to confirm that, okay, if something will happen, there is no impact on that. So what happened during installations of this application, when we are launching an application, before launching the application to the end customer, there is a IT industry concept is that, okay, in your project plan, have you tested disaster failure or not? Failure testing happened or not? So what will happen in that case? The entire data center will be shut down without informing that testers, and ask them to continue their testing such that the same is available from their endpoint of service. That's mean that if you have a data center in Mumbai and if you have a data center in Kolkata, so you are going to shut down the entire data center in Mumbai, and there should not be any disturbance in your application because it will be served from the Kolkata. So what will happen that it's a huge cost, and even its data center, whenever we are talking about it, this is very challenging because most of the cases, in India cases, we are taking that data center is different region, different state. There are a lot of funding is required. lot of state-wise there are different rules are there. So there are different challenges are there, and overall there is a high cost is involved because we are not utilizing this thing. Whereas in cloud we have a concept of regions and zones. What do you mean by regions and what do you mean by zones? Region means in a particular location. It's a city. Okay, it's a city. For example, London region. London region is very popular for the AWS and GCP and Azure because everyone has that their data center. Actually, ultimately, cloud they should keep some data center, right? And in that particular region means that is a specific region where they have it. So now every cloud provider like AWS, GCP, Azure, OCI, that is Oracle Cloud Infrastructure, Alibaba, they are the big cloud provider who are actually building their applications and keep increasing their number of regions throughout that world. If you go to that any website, you can see that what's the plan for the regions. Okay, every regions have a connectivity with that high bandwidth point of sight. There may be if it is in the same country, there is some fiber cable being connected, or if it is not, it's over the satellite connectivity. But these regions are well connected. Okay, well connected so that all replication is being happen properly. And if any happen to the entire region, there would be no impact on the application. Their entire application being copied from London region to say US region. Some US we have multiple regions also. So regions means it's a specific city where the data center is, and within the region there is a concept of zones. Okay, so what happened is within that region they have created separated data center which might be interconnected with a high bandwidth. So in London region, say I have say 2 data center. They have in AWS. I think they have a three zone. Okay, in London they have a 3 zone: zone 1, zone 2, zone 3 in AWS and as well as GCP. So what happened that if some of the zone, so zone means it's a complete separated infrastructure in that particular region. If entered it, you can treat it as a sub data center. Okay? So entered zone is even not available. Suppose if there is some power down happen on the zone 1, instead of that your application will not go from London region to Mumbai. Application will serve from the London region but from different zones. So whenever we are implementing that cloud solution, I will go through some of that slides where what we have implemented for the London region. So whenever we are implementing that some cloud solutions, we have to make sure application is running as a zonal failure. Zonal failure means that our application should be, whenever we are implementing that application, we have to make sure, okay, application has the zonal failure. That means if one of the zone is not available, instead of that application should be running. So our application will be scattered in the zone 1, zone 2, zone 3. And there is some configuration process also in the cloud. And if customer is asking, no, I want not only zonal failure, I want the regional failure also. Why? In that case, we have to implement the application zonal failure and in the regional failure. So if entire London region is not available, then still that application will be served from say Frankfurt, that is in Germany region also. Okay, so that's mean data will be replicated from one region to another region, so that all the data can be available and there will be no impact on that application. Like some of the applications which should have the zonal activity, like for example, we don't know that we are using photo, right? Google Photos. We are uploading our photos to the Google site. Okay, and what happened? What happened in the Google Zone? What will happen in the Google site? Photo we are uploading. We don't know where we are keeping our photos, where they are keeping our photos, right? But if it is being uploaded in India region, they have in Mumbai data centers also. Okay. They are uploading in India data center. Doesn't mean that if Mumbai data center is not available, doesn't mean that we are not able to access our photos, because it's being replicated from different region also. So if you are moving to that London, if you're moving to the US, you can access your photos from that location, and because it is being copied to the different region itself. So whenever the customer is looking that, okay, I don't need only that zonal disaster recovery, I need the regional disaster recovery. In that case, that regional failure will be, which is very challenging whenever talking about the on-prem application, on-prem data centers. Collaborations means we can collaboratively work with that multiple organizations, multiple service organizations with the multiple data cloud provider and multiple service providers. So nowadays what happened, there are a lot of software companies out there who are providing that their services like CRM services, billing services, which being customized by the applications teams, okay, the development for that specific customer, that being deployed on the production. But now once we moving to that cloud, does it mean that they are stopping their activity? No. They are actually uploading that their services to the cloud, such that anyone who are using the cloud, their service can be available from that cloud itself. Suppose CRM services being available on AWS, CRM services available on from cloud, from GCP, Oracle, anywhere else. Okay, so they are actually uploading their services to there, and that is called the marketplace also. And there is a flexibility and in computing. This is very much flexibility of what I'm the same thing, that is accessibility is very much very fast. We can provision our application and implement the thing. In computing research, and as you know that nowadays huge number of green evolution is happening right throughout the world. What happened? This data center being instead of, if we are having multiple data centers, there are a lot of power consumption will happen, right? And AC would be happening. So instead of that, if you are moving to that, it is centralized different locations. So as they are implementing their hardwares in such a way, less computing and less power carbon being emitted to the world. So there are individual companies, they have some target how to reduce that pollution throughout that pollution. Like you may heard about the some days back, Azure started working to keep their entire data center underwater and under sea. Okay, that will help that reductions of SEUs, right? If you have anyone have visit even from your college also, you see your data center being always, we have to make sure it will be freeze. It's at least 1 or 2 degree temperature. So always AC should be running, right? But instead to avoid these things, there are a lot of activities being doing by the cloud. So these are the advantage of that cloud. Okay, and whenever we are talking about the cloud, these are the very much advantage. Obviously, disadvantage I have mentioned right hand side, that dependency of always internet connectivity. Like we guys are working or talking each other over that Google Meet. Now that's been we are using GCP services, GCP SaaS services, and if I don't have the internet, I'm not able to provide it. So there obviously that's mean if we are accessing to that any cloud services, there is a high dependence on the internet. I'm not saying that 100% because nowadays all application can be accessed over that private connectivity also, but it's very less. Okay, most of the cases which we are using that over the internet, we are accessing the infrastructure and applications. And major things is the security concern. So why we are talking about that cloud movement? Whenever we are talking about the cloud movement, there is a new thing concept is the cyber security. Now you are implementing your entire applications to that cloud. Now we are accessing our applications over the internet from the cloud. So that's mean your entire banking application is being installed in that some different location in Mumbai, and that is under GCP. Okay, Google Cloud providers. Okay. Now where is the security? That okay, there has been no leakage in our data information. Okay, how we are securing this? Even India, we may not have too much concern about that security, but Europe region is very high. Okay, it's not like US. US is also security not being high, but Europe region security is high. The customer privacy is very important. So that's why how we are going to implement this application is how we are going to implement the security is very crucial. Whenever we are starting on the cloud provisioning, like I will try to go through that some of the sample, but nowadays this not being used because security is so how the normal way we are implementing our application solution not being accepted. So there is a new concept is a private service connect where we don't have the connectivity with that PPC peering or something like that. I will try to convey the same thing. So security is day by day high because whenever we are implementing, we know that is a cloud solution. There is encryption, there is a PPC concept, but still there are some leakages happening in cyber security. Cyber crime is increasing day by day. So this is the security concern whenever we are provisioning any application to public cloud. Security is related to the data privacy and compliance again. So downtime is a very challenging. Downtime is a very good concept. Okay, now every time they are saying that okay, cloud provider saying that okay, we may not have downtime, but they are not saying that okay, it would be 100% available. If you go to that each and every cloud services, there are a lot of thousands of services are available in the cloud, and each services are coming with that some availability point of sight. They are saying that my server will be available 99.99%. They are saying that my storage will be available 99.999% time. So, but still downtime may happen on the cloud, but it's cloud is trying to recover this time, but there should not be downtime. But we have to implement the solution in such a way that there should not be downtime in the application. Major challenge is vendor locking. Okay. For example, if you are implementing that applications on AWS cloud, okay, and we are using AWS services, and we customize our application using AWS services and our custom code, what will happen now if you see that the cloud cost is being high? Actually, ultimately, we don't have any data center, right? We have only that we are using the cloud services. Right? We are storing the data, we are executing compute from the cloud itself. So we are tightly bound with that service provider. So, but AWS sending a huge bill every month, and we are able to see that okay, now GCP is giving a little bit cheaper rate. Okay, now that's when you want to move your application to GCP. It's very challenging because we are using AWS services, and on top of that, we have done some customization. So, vendor locking is a very challenging whenever we are talking about the cloud. Cost over the time. So, initially the cost is high in the cloud, but slowly, if you find out how to reduce the cost, that is very good approach. But initially, whenever we implement into that cloud, suppose I told you when we are starting in the discussion, when we start that any cloud moment, our application is running fine, then why should we move to the cloud? So, but there are multiple reasons why we are moving to the cloud that I mentioned in that conversation. So that the cost being high, if we are initially, but slowly it can be reduced with that based on the utilization. So there is a concept of FinOps as cost minimization team who are actually daily basis working. What is the utilizations of services? How can reduce that, replace the services with a lower configuration and give the same support without any downtime. Major challenge is migration complexity. Migration complexity is so high. Migration complexity so high means suppose your application is running on on-prem, and if you are moving to the cloud, it's not so easy. Each and every application, and now to move to the cloud, it's very challenging. There are a lot of steps are being followed to the cloud. compatibility issue. Suppose your services being you have written in on-prem and you want to move to the cloud, you may observe that your services which you have written some C, C++, that is might not be supporting on the cloud provider. Nowadays, there are third-party software they are asking to use. But there are some compatibility issues because the services which you are using in that on-prem application, all the services might not be available. We're talking about the small applications that can be, but whenever we're talking the enterprise solution, there are a lot of services we have written as an application developer that might not be supported to all the things. So the compatibility issue with that. So that's the main advantage and disadvantage I'm trying to explain. And let me go to the next slide. And this is very interesting slide. And I understand everyone has seen this type of feature. Okay, and why I'm showing this slide? Okay, infrastructure as code, platform as code, service as okay. So what do you mean by IaaS? What do you mean by PaaS? What do you mean by SaaS? Okay, software as a service, platform as a service, infrastructure as a service. Okay. Now, if you see that entire application is on-prem, that is, your entire application is running in on-prem. So that's mean as a service provider, you are responsible for everything. You have to manage your networking, you have to build the storage, you have to server, you have to virtualize and things. There is a concept of that VMware being very much popular or on that virtualization point of sight. You have to manage your operating system, you have to manage the middleware, you have to maintain the runtime, data, application, everything. You have to manage yourself because you are not responsible only for the application. So if any issue happening on the networking, any issue storage, you are responsible. Okay, because cabling, server racking, server replacement, everything on top of the servers, you have to do the virtualization. That is, you are responsible on for each and every operating system. It is being changed. Then in that case, you have to upgrade the operating system, everything. So if it is talking about that on-prem, that's when you are responsible for each and everything to build the application and providing service to the end users. Infrastructure as a service, what they are saying, okay, forget about that core infrastructure. Okay, I am giving you the server. I am giving you that. What service provider saying that AWS and GCP, Alibaba, they are saying that okay, I am providing the core network. I am providing the storage. I am providing the core server. I am doing the virtualization. And in the top of the virtualization, you manage your operating system. You manage your middleware. Middleware means that Tomcat, okay, and web services, right? So you manage your runtime, you manage your data, you manage your application. So this is your responsibility. I can give you that core infrastructure. That is called infrastructure as a service. Next is platform as a service. So what they are saying that okay, you just deploy your application. I will manage everything. So runtime, middleware, OS, virtualization, servers, okay, storage, networking. These are called also known as managed services nowadays. Managed services. So what will happen? Okay, you are saying that okay, I need to deploy my application in Docker container. Okay, can you give me that container? They're saying okay, I'm building a container. You just deploy your code. Okay, so and the data. So this is called that platform as a service. Okay, and I'm not going to in deep. It's a very vast area, and even every day we are learning on that area. Most of the organization is working on that infrastructure as a service and PaaS as a service. Okay. Last is SaaS. What do you mean by SaaS? SaaS means okay, least bother about the things. Service provider are saying that no need of customization, no need of anything. I can give you everything. Okay, what do you want? What do you want? I can provide you that SaaS. And there is a very popular SaaS nowadays. That is Salesforce. Might you heard about that? Salesforce being very much popular CRM application. What they are saying that Adobe is another SaaS application. What they are saying that what do you want? You just tell me. I am creating the application for you. I am managing the infrastructure, I am managing the application. You don't need to bother. Everything, what do you want, I can provide. So that is called SaaS. Even daily basis which we are using, like Google Photo, Google Mail, this is a SaaS, because we are not doing anything. We just creating a one account. We are using that all the services, right? We least bother where they are keeping the data, and how they are keeping the data. What is the network? If there a disaster recovery happen, how they are managing? Is there inside there in the operating system? Is there any applications, virtual machines there? We least bother. What we are doing? We are using mail services. We are using photo services. This is SaaS. So there are a lot of SaaS applications here there. Whenever we are doing some enterprise solution, multi-cloud. Okay, now I can give you on one example. I was working with for one of that European client, telecom client, where they ask that entire digital transformations, and we almost assign more than 1,000 people to work on that, redesign that entire applications. What happened? They have 130 applications running, okay? And they told that okay, these applications are not serving the latest features, and as well as some of the applications are duplicates. So can you do that modernizations? So what we proposed, we create a new set of application with that APIs, databases, and using that some SaaS, like we have taken the Salesforce, we have taken Adobe, we have taken AWS, we have taken GCP, we have taken Azure. So it's a multi-cloud solution, and implement the entire application in infrastructure and minimize the number of applications to 10 to 15 applications. So instead of managing that 130 application, they have to manage now only 16 application, and that's the multi-cloud solution. And with the digital transformation, it's a huge work, and still work is going on. So digital transformations and modernization is the new feature of this organization, IT industry, which is happening day by day, and how we are legacy application moving to the cloud. So these are the concepts which we are using on the cloud. Okay. Now there is a concept of migrations. What do you mean by greenfield and brownfield migration? I'm simply reading that. I think you can understand it. What do you mean by greenfield migration? Greenfield cloud migration is the process of building a new IT infrastructure and application in new cloud environment without any existing legacy system or data. So that means, suppose if you are launching a new application, complete new application, at least bother about that old application. Complete new application you are building, and that is called greenfield application. And brownfield application, it's an existing application which is running on on-prem, okay, and or maybe on cloud. We are modernizing or changing this application and moving to the cloud. So not too much in it. The brownfield applications, okay, you observe that your Haldia Institute of Technology's entire system you guys are using, right, that has on-prem uses, and think that okay, every time we have to align that resources to manage this application, better to move everything to the cloud. Okay. But there should not be any impact on your existing applications configurations. Okay. Just move to everything to the cloud. This is actually existing application, you are moving to that cloud. That is called the brownfield application, brownfield migrations. There are some other concepts now. Unfortunately, that teaching industry, because we have to concentrate on that teaching point outside the core part, and then followed by that latest technology. But cloud last 10 years so modernized, so changed. So there are concept of cloud ready and cloud native. So cloud ready, actually it's little bit old concept. When that okay, I can give you the infrastructure, but there is a no impact in your existing application. So it's a just lift and shift. Okay, when we are not using that cloud services, native services. So you may heard about the virtual machine. Suppose if you have a servers running on your application, we're just moving the same server to that cloud. Okay, the cost is not too much significant changes, and as well as that modernization not happen. We are not using any cloud services. So this is called the cloud ready. Okay, and cloud native means that we are utilizing the cloud services and modernize our application. So there are concept of serverless code. Okay, Cloud Run is called, Lambda function is there. So what are these? What are the things? These are Lambda function or Cloud Run. They doesn't need any server. You want to execute some script, you just write your script, cloud will do that execution of this script. They don't need any server for that. Okay, so this is the services as called the cloud native services. So cloud native services means you are leveraging that services being provided by the clouds. Sorry, anybody is speaking? Sorry, any question? No. Okay, so cloud native solution means that if we are leveraging the services being provided by cloud and we are building our application on based on that cloud native services and implementing the entire application. And if you want to know that cloud native services and just Google it, cloud native compute foundation CNCF, because this is a freeware where you can check it. Lot of tools and technology they are providing, and it's been robustly increasing. You may heard about the Kubernetes clusters. You may heard about the Docker. These are the part of CNCF. And if you have to do some online testing, okay, online hands-on activity on that Docker, Kubernetes, okay, you can go in that online Docker training courses. Cloud Code, okay, Cloud Code is a website where you can go and log in and you can execute all that latest technology without provisioning any cloud softwares. It's a free. Okay, obviously there are some paid things, but you can go to the Cloud Code. They can create you the cloud cluster. They can provide you the virtual machine where you can write your code, where you can check that commands. You can execute what do you want from the cloud point of view. But whenever you are logging to the cloud, that means the cost in law. Obviously, AWS, GCP, they are providing that 3 months, 1 year subscription, free subscription for the student activity. But if you are looking for that Kubernetes cluster, okay, and some services which is very high costly, whenever you are building the Kubernetes cluster on the cloud, obviously it's almost 250 GBP like that. So it's a high cost. So instead of doing that, you can check your coding to the cloud free website where you can execute and learn a lot of things. Okay. What next? Let me go through the quickly. Next first is the target architecture. This is very interesting thing. In the cloud migration is very crucial whenever we are proposing. Suppose they have current organization, because most of the organization now you understand, like modernizations has already happened last 50 years, right? All the organization they have some application. We are not building, most of the cases we are not building a new application, right? There are some existing, like banking system, they have some existing application. They want to modernize this thing, they want to move to the cloud. Okay, so that is called that cloud migration. Whenever we are talking about the cloud migration, there are some called as the best art treatment. Okay, there are some art treatment is that. So we have to design and we have to study that application first. So that okay, what we should do on that application? What are the 6 R's? What are the 6 R's? Shall I retain the application? Shall I retain the application? Shall I rehost the application? Shall I re-platform the application? So do we need to repurchase anything for this application build activity, or refactoring things, or re-architecture the entire application? So these are that 6 R's, very much crucial whenever we are talking about the modernizations of the existing application in the cloudification part of it. And I mentioned some of that effort, time, cost, and optimization, opportunity to optimize. Okay. So if you go for the refactoring and re-architecture, if you observe that, okay, that means we are modernizing that application. Whenever we are talking the modernizing the application, that means there are more feature will come in, but initial effort is high. Initial optimization is obviously high, but effort is always high. If you go for the latest refactoring point of sight, these are that R6 R factor, but I think it's not very much crucial for you guys to understand this thing, but it's very interesting thing because what we are doing in the cloud migration. What do you mean retire? Retire means that okay, this we observe some of the application. There is no use, no one using this application. It's rarely there are couple of files is being processed and which can be hosted on the different application server. So this in that case we are proposing okay, let's retire the entire application, not hardware. Let's retire the entire application such that we can get it from there is no need of migration side. And we found out there are some crucial things, some of the applications that it should not go to the cloud. Okay, there are some audit data, there are some old technologies running on the application which modernization is impossible. So what we are saying that keep the application. Okay, we are not able to move to the cloud, but effort is little bit required because we have to investigate this application. Rehost means that we observe okay, application has to move to the cloud because EOSL is happened, the end of service life arrive for the infrastructure. If we are moving this, keeping this application on-prem, we have to purchase a new server, data center, and different data center for disaster recovery. That is cost effective. So better to don't do anything, don't change the applications too much. Just do the rehost. It's also known as lift and shift type of. So it's also rehost means suppose if you have a from one operating system to another operating system. So suppose if you have is an Unix and you are moving that okay to Linux, okay, and we also there is not too much changes in that in underlying software. So in that case we have to focus in the rehost. There is a concept of re-platform. What do you mean by re-platform? Okay, so it's a change on that infrastructure point of sight, operating system point of sight, and something like some parts product system, but very less effort because we're not too much changing that code, underlying code, right? Suppose you have written C++ code, okay, but that is a Java code that is not able to that can be hosted on any hardware, that can be hosted on any operating system. So in this case, we propose a platform. Right? For nowadays, what happened? Most of the database we are keeping in the Oracle database, right? And it was the one time I'm talking about 10-15 years back. We thought the Oracle is that Oracle will be everything. Okay, Oracle will the way Oracle is going. Oracle will do everything. Also, whenever we are talking about that, okay, Oracle will be the database. Nowadays, there. IT industry try to move out from the Oracle database because its cost is high, flexibility is not so much. So there are a lot of new operating databases already arrived in cloud also. So instead of keeping in the Oracle database, let's move to the get rid of the Oracle database. Repurchase, another thing. Okay, and refactor and re-architecture, which is very latest technology like Kubernetes cluster, microservices, which is called is required. So this architect analysis, whenever we're talking about that cloud migrations, we have to go through that server, maybe applications, 3 to 4 months. We are just doing this assessment so that we identify that R factor for each and every application. Okay, now if you see that we are dividing that the activity in two ways. At one called is migration factory, another is change factory, right? Rehost, re-platform, retire, and retain. This is migration. Actually, we are doing that migration of this application, right? And whenever it's change factory, means we are doing some changes on their existing layer. We are not changing the functionality, but we're changing that underlying application, underlying infrastructure, underlying way of reading the code. So refactor, replace, rebuild the relations. These are the part of that change factory. It's a division, okay? Migration factory and change factory. And I mentioned a little bit where should we consider the migration factory? Where should we consider that change factory? Like Windows servers or above Red Hat Linux and above, which we are rehosting. Okay, Red Hat 8.2, we are moving to the latest Red Hat. Okay. Windows Server to moving to Windows 10 to Windows Server 26, 2016. EOSL operating system we are moving. DB upgrade, which is a part of that platform. But if you're changing everything, Oracle to MySQL, okay, Oracle to Postgres, okay, this is called that refactoring and part of the change factor. There are some steps whenever we cloud movement happening. It's a big team being organized. Cloud governance team is there. Cloud operations excellence team being designed, which actually monitoring that some of the phases, like what are the phases we have to consider. Initial phases, business case scope, everything is being considered. Like initial strategy planning, we are doing discovery assessment, roadmap creation, SOW configuration is happening, migration planning and design architecture is happening, then POC and pilots is happening, build and migrate the modernizations, and observability and monitoring. Observability monitoring is very crucial thing in the IT industry. Now we understand from whenever talking about that, okay, one application, we may not understand that what is the observability and monitoring. Now in a organization, in enterprise solution, like in a banking solution, they have 1,000 servers, they have 200 applications, and each and every applications are interconnected, right? Now if you open your mobile app, you can see nowadays there are in SBI Bank, Kotak Bank, if you open that mobile app, you can see small of services are available, okay. Money transfer, nowadays what you can phone pay, right? These are the services which we are using. A lot of small services. Now you can check that transaction details. Okay, there's small icons are there, but each and every services are not linked with each other. So all the services can be changes whenever required. They are not taking the entire server application down. Sometimes you may observe, okay, this service is not available. So these are implementing that using microservices, using Kubernetes or Docker, okay. But so that's mean it's not like that. If anyone have gone through that my Docker containers and actually cloud runs or cloud serverless functions, you may observe that there are thousands of applications or services are running on the cloud, right? Suppose if you have a 200 application, you have 1,000 servers, and you have 5,000 network elements, right? So you can monitor it. But nowadays, what happens is microservices are coming. Now, how these services are running on level and that cluster level instead of only the server level. Till now, maybe at least 5 years back, we were talking about the observability and monitoring is server level. No more is server level. Now it is the application level. Inside the application level, it is a microservice level where the observability and monitoring is happening. Then slowly operate and optimize. This is the last stage for the cloud migration. When once we everything is running, and every year we need to find out that how to optimize the cloud utilization, cloud server cost. Okay. What should I go to the next stage? Let me go through some case study. Okay. This is that one application. I try to minimize these things. Okay. If you see this application, it is for AWS. Okay. What this application is doing? Okay, and it's might be you guys break to you guys because if you don't understand AWS is considered very high capacity, complex architecture. Okay, where what we do, we implemented one service. Okay, and the service being installed in 2 availability zone in London. I told you sometimes back, right? In region and zones, right? What happened? We implement that Kubernetes cluster. This is called the Kubernetes cluster. It's not a virtual. It's a collection of virtual nodes. Okay, and if you want to know that Kubernetes things, it may require 3-4 days to understand what you mean by Kubernetes and how it is work. But it's a cluster, Kubernetes cluster we have created on 2 availability zone in London. We have 3 availability zone, but we have considered 2 availability zone. In that availability zone, we have created Kubernetes cluster. In that two Kubernetes cluster being running in two availability zone in such a way that is called EKS cluster. Okay, that EKS cluster has some logical separations with that services. Suppose if you have a banking system, right? For example, if you have a banking system and it has a credit card system, it has fixed deposit, it has a savings accounts, it's have a billing, it's have a customer information, right? So these are the informations we have in a bank, right? So whenever credit card related activity is happening, obviously the application which we are using for that saving account we might not use for that credit card services which we are using there, right? So what happened in that we are using the same infrastructure, but we are doing some logical separations. Logical separation means, okay, created namespaces in that Kubernetes. Okay, in the namespace, say namespace, one namespace is credit card, another namespace is savings account, another namespace is for fixed deposit, another namespace is for the customer informations. Okay, now but underlying infrastructure are same, but this underlying infrastructure is running on Kubernetes cluster. So layers are different. There are some lot of layers. Okay, actual layer is our physical layer. That is our node pool. Actually, this is the collection of virtual machines, and that's virtual machine. On top of the virtual machine, we have created a Kubernetes cluster. On top of this cluster, we have created a logical separation that is called namespaces. Okay, where this namespace is being used for individual services. Now you have written some Java code for credit card, and you have written some Java code for savings account, and these services are running. Your services is running on the Docker or container, because you can write in your program in Go. Okay, and someone has written in Java, but it can be containerized in different Docker images, and that can be deployed here. Okay, and different services. So what happened is very complex architecture. You understand that the infrastructure we have is sample infrastructure is there, or underlying infrastructure is same. That is some couple of virtual machine. But on virtual basis, we have created Kubernetes cluster, and in this Kubernetes cluster, we have deployed containers, and top of the containers, we have done that logical separations. So we understand that within this cluster, we have a lot of communication is happening, and so we need to monitor these things. And it's very complex. Nowadays, this Kubernetes is very much popular because modernizations or customization is very fast if we are using the Kubernetes cluster. But if you are using the cloud ready concept, that means your application is running in different server and XYZ application is in different servers. That changing anything that is very challenging. Instead of that, if you are implementing your application in that container, change is very fast, because you can write your code in Java, you can write your code in Go, you can write your code in Python, any language. You write your piece of code and deploy into the Kubernetes cluster as a container. But managing these things, we have to use either cloud EKS cluster, that is it's a one concept of manage of cluster. If you are deploying in the GCP, that is our GKE. Okay, and concept wise both are same. Now this is totally internal services, right? What end user doing? We are just accessing my bill statement, right? We are clicking one button, and that will give my bill information. A transaction, we want to do that transaction, we are source and destination or account number we are putting, right? So all the application is happening internal, because no one is accessing your data. If whenever you are doing some transaction, some other people are not able to see that application, right? So that's why the entire information, whatever way the transaction is happening, that we have to keep in the private subnet. If you see, let me point that. Okay, if you see, I have mentioned this is a private subnet. private subnet. Okay, so this private subnet happened. It is the private IP. It is not internet IP. No one able to see that what is happening inside. Okay, so the entire transaction is happening inside this private subnet. And how this private subnet being fetching that the request from the load balancer. Okay, where is the load balancer? If you see, the load balancer is here. Okay. This load balancer providing the services to here. So that's mean we are accessing this load balancer, sending that. Where it is? This is in public subnet, which has the internet IP. How this being accessed? There is the route 53. This is called the DNS service, which being accessed by the end user. This is you and me, right? We are accessing that this web URL. From this web URL, it is going to the load balancer. From this load balancer, it is going to that Kubernetes cluster. So my request is coming here, your request is coming here, another request is coming here. But now this request and this request are not able to see each other. So cybercam, they are not able to see anything what is happening inside this cluster. So make sure your entire functionality should be written in that private subnet. And we are running this application in EKS cluster. This is a service is provided by AWS. It is a Kubernetes cluster, and when all the services which we are written in using Docker and Docker container. Okay. Now, how these people are accessing? Now, these people are accessing from here. Now, whenever we are accessing this application, right, we have to do some authentication, right? This authentication generally we are managing from Active Directory. If you may have heard about that, Active Directory. Active Directory is very much popular services provided by Microsoft Azure. And there are a lot of SAML. This is also known as SAML authorization. There are a lot of authorization mechanisms available. But industry-wise, very much popular is that Active Directory. So most of the company, they have application. If you see, this entire application is running in our AWS, but authentication and authorization is happening on that Active Directory, which is reside on Microsoft Azure. Okay, and this is a different technology. So there are, what do you understand? In this, to implement this infrastructure, this application, we have expertise people who know that Kubernetes cluster management, who know that Dockerizations very much, who know that AWS very well, who should know that Active Directory very well, and who know that how these applications can be secured. And overall, ultimately, if you understand, this is the infrastructure configuration and design, but ultimately the application someone has to write. So here, this entire business logic and business development need to by the developer guys. So that's mean Java, Go, Python, JavaScript. These are very much popular nowadays, and this being used. And obviously, database will be there, but we are slowly moving from the RDBMS to that document DB and not NoSQL pointer side. Okay, and get read from that Oracle. Truly speaking, last 5 years I'm not working Oracle. Everything is moving to that from Postgres, MySQL, which are very much popular in the cloud services. Okay. And now, problem is this: one who is doing this implementation, this we are separating this infrastructure from another infrastructure. From this infrastructure, actually, this is our application, right? This application is being accessed when we are building. We are building from another side that is called different VPC. This is in zone A, where we are doing that transit gateway, VPC peering. There are a lot of concepts are there. VPC peering are there. How do the VPC peering? What do you mean by VPC peering? How they are communicate with each other? Nowadays, VPC peering means that actually one network will be communicated with another network. Okay, but security restriction is coming in there nowadays. Okay, they are asking not to use that VPC peering. Use that service attachment. That is a new concept. It's a latest technology. And if you see in below statement, how we are doing these things, You may heard about the GitHub, GitLab. Okay, this is the repository or where we are doing say the CI/CD implementation, because every time whenever we are once the deployment is done, if the infrastructure build is done, we should not least bother about that. Every time if code changes happening, we should not do any manual changes. Everything done need to be done by. If you see that cat sign here, okay, this is a Git sign. Okay, we are using this GitLab for the CI/CD. There are more function is there, storage is there, some other S3 bucket is there. These are concept on AWS. Okay, I'm going to the next slide. Sorry. Okay, now I'm trying to explain you another service. It is a for GCP, Google Cloud Provider, which we have a provide that another Europe customer. Okay, what they are saying, this is a telecom organization. What they are saying, okay, they are saying that okay, we can provide the service. We are service to end consumer, but it's not that you have to purchase the service from me. They are wholesaling the services. Okay, wholesaling services means they are providing the services to the end customer. Have you heard? You observe that people are doing trading, right? They're trading. You have lot of trading company websites, right? Broker, right? There are a lot of brokers are there in trading organization, but ultimately they are getting the data from our NSDL side. NSDL, what NSDL are doing in that Indian government, NSDL has a service. They are actually exposing their APIs to that internet. So if you want to implement your application using that that APIs, and you use that, ultimately you are using the API. So what happened? One of the customer told us, okay, we want to expose our services to the customer, not internal service providers, such that they can use my services and sell to that as a different customer. Like what saying that okay, someone is want to deploy some phone. Okay, they want to sell some internet connection, home internet connection. What they are saying that what I am doing, I'm not going to go end customer. Okay, what they are saying, okay, my services are available over the internet. Suppose some company, some local company, they are saying, okay, I want to use your service. I will sell your product to individual people. So that's mean I'm currently in Kolkata. Suppose I have created one shop from where what I'm saying that we can establish the Reliance services. So what I'm doing, I am just using Reliance services and holding the customer. I am saying that okay, I am just implementing your cabling. I am going to implement your internet services. What I am doing, I'm convinced the customer, and I'm docketing this thing. But I don't have anything because I don't have the Reliance infrastructure, anything. What I'm doing, I'm just creating a one service ticket and from the website, and Reliance company will do that rest of that. So this company, what they are saying that we want to wholesale our services to that client, not to the end customer, to the some of that users, okay, who can sell our product to the end customer. So what we have done, we used we create a one applications. This application will be all the business logic, application logic is getting in the Kubernetes clusters, okay, and this is being the service is being provided to that create a API layer. Okay, this API layer being published by APG, okay, and this So this API being accessed by the end user, and they are using these things, and its entire things, if you see that, we are actually exposing this API to the internet, whereas our actual application is running in that downside. Okay, so this is the one service. So every challenges is there. So whenever we are doing something, okay. Now these are that I can go to that to examples I am explain you. I don't know you are able to understand or not, because there is a concept of whenever we are talking about that cloud things, we have to implement, we have to understand the basic things, that is networking, because ultimately they are providing that core infrastructure, but virtual infrastructure we have to build, right? We have to create the subnet, we have to create that VPCs, but VPC virtual private cloud. Inside the virtual private cloud, I told that we need to create the public and private, and then from there we can host their Linux server, something like that. So what I'll do, let me expose some of that website. Sorry, let me open that services which I actually am working from my personal laptop, which is not being used so many frequently, because nowadays I'm not getting time. Let me go open that. It's slow. Okay. Are you able to see my desktop now? If you see that, this is AWS console. I have logged into the AWS console, and anyone can log in. Anyone can log in. Okay, anyone can log in. And why I am saying that now, I know that these sessions is happening on that AIML and cloud computing, but ultimately AIML, which been coming from the most of the organization, they are hosting these services to some of the cloud providers. So if you see that services there are a lot of services being provided by that cloud. I think 400 plus services being provided by the AWS, 300 plus services being provided by GCP, and it's being daily basis they are increasing that lot of. If you see that, what do you mean compute? Okay, this is if you go to that AWS console, this compute means that servers or computation which is providing the computation, right? There is a concept of EC2. It's called as also known as virtual machine. Logstail. This is another thing. Lambda is very much popular. It's a serverless. Suppose if you want to execute some script, you can write your Lambda script and just execute this thing. There Elastic Beanstalk. There is a serverless application repository, AWS Outpost, EC2 image builder, AWS application ladder, AWS SIEM space wherever. Even I'm not using all the things. If I am using, if the customer requirement coming, if we have to find out that which services we should need from that AWS, then that services we are considering and creating that complete design. So cloud is huge. If you see that there are a lot of services being provided there. If you see the security, identity and compliance, so how we are going to implement the security, there are a lot of security features being implemented. If you are talking the analytics is initial stage of data analytics, right? This is data analytics part is there, and it's a part of the AIML part also. If there are a lot of services being implemented already, we need to use these services. I'm not part of that AIML part too much, so that's why I'm not aware about that on that. If you want to use the mobile software, there are services that are available. Okay? And machine learning, if you see that these are all the machine learning services is already available from the AWS side. Okay, that's mean that already the that machine language part we have learned that okay, we have to give the lot of service training data so that machine language AIML can work properly and give the proper model. We have to create the model, right? But in that AIML already they have created a lot of models. You may have heard about the ChatGPT. It's a very much. It's a revolutions which is actually changing. I'm daily basis I'm using ChatGPT. Anyone can go to ChatGPT. What you want, you can write down in the chat GPT, you can get it immediately. They will guide you how to proceed. For example, how to install some, suppose if you want to write some bubble sort in C++, will give to that, just write down that, okay, I provide me the bubble sort program in C++. Quickly it will give to that C++. So that's the revolution. So that's mean, obviously that will destroy some of the creativity, but it will help to the IT industries to implement that services very fast. So similarly, like ChatGPT, what they have done, they have created the services, use that AIML and implement the model already, so that whatever with the problem you have, they can provide the solution. Similarly, there are a lot of AIML services that are available in that AWS area. There are a lot of things if you see that, but most of the cases, like I am using, because if you in the core point of sight, we know that storage, we know the compute engine, we know that clusters, EKS cluster, the container, I took that container is a cluster. If you see the database point of sight, see that RDS, Elasticsearch, Neptune, Amazon QLDB, Amazon Document DB, Amazon Keyspaces, Amazon TimeStream, DynamoDB, Amazon Memory DB for Redis, and RDS is that feature actually where you can do any third-party database here. In RDS, you can implement Oracle, you can implement PostgreSQL, you can fill MySQL. So these are the RDBS services are being provided. Okay. There are migration subs. So a lot of things is there. But similarly, if I go to that GCP site, I have some GCP here. We have a GCP sites also, GCP console, where you can go and learn something. And if you register yourself, it's a free, you can Google it, find out how to register. It's very simple. And you will get the 3-month subscription, £300 or $300, where you can do anything. And once this amount is crossing, delete your account, create another account, another mail ID, you can do the same thing, which we are doing daily basis, right? But fortunately, we have not to do that because we are in organizations and where we have the full access to create the services here. But for the learning purpose, when we have started the cloud, when I was not a part of the cloud, I started my learning from that free subscription itself. Okay. Now, how we are going to start the cloud journey? How we are going to start the cloud journey to the people? Why I am saying that is, you understand this cloud is so huge. It's not possible to train the student from the day one itself. So what we can do, we can train the ambience. We can use the platform of the cloud platform, like ask that all the student to run that all program which they are writing in Java, C++, everything should be in that cloud side. And if they are using AWS, you will get that one year subscription, free subscription, and that is huge amount that we can use. Like here, if I go to that AWS side, in this AWS side. Okay. If I go to the EC2 instance, I'm not going to create the EC2 instance. You can do it manually, and you can do by scripting. EC2 instance, I'm going EC2 instance now. If you see the right hand side, we have some regions. Okay, this is all the regions we have. London regions, okay, and Mumbai we have in India. In Asia specific, you see the Mumbai is that region is there, and I am currently in that region. I think I have created some of the instance on Node Virginia USS1. If I go to that instances, I don't have any instances are running. Okay, let's cross it. Okay, I have created a couple of instances here. You can click it manually from launch instance test menu. You launch instance, there are services can be created automatically. Okay, and let me just run some instance. How we are going to create? Okay, let me start instance. It's running. Great. Okay, it's running. Now, if you click that, there are some information you can see. A lot of information, not some information, a lot of information. This is instance ID. It's a public IP. I have created this instance on public subnet so that it can get the public. It can be accessed from the public side. Okay. We have a private subnet, and the private IP is every inside it is being created a private IP also. Okay. What instance type we have selected? T2 micro services we have created. Okay. Now there are some networking details is there. What type of platform I use? Ubuntu operating system I use. Okay. Platform is Ubuntu. Platform details is Linux we are using. And what type of image? This is the image details is there because image being changes daily basis. Okay. Now I'm using that free version, but in organization we can't use in enterprise we can't use any images because security concern. Every organization has their own proper images. That images we have to select from the some image repository itself. So these are that some information. If you create something, it is very simple. Why I'm showing this is manually. You will Google it, you will get it. I will come to the next slide, next activity, which I am trying to explain you that Terraform script, how we can quickly create the infrastructure very fast. Okay. Now this server IP is like that. Okay. Now if you want to access this server from your local desktop, you may have PuTTY, you may have the mobile X. Okay. So there is a command that you can start this SSH. Okay, -I. You have to, when you are creating these things, you have to download one key. Okay, if you see, this is the key. When you are going to create these things, it will create that. It's 10-15 minutes required, so that's why I'm not creating. Whenever you're creating, there will be creating a key. Okay, you need to download this key. You need to keep this key somewhere, and path of the key. That key is generally coming as a PEM format. Ubuntu user, this is the launching user. It has a sudo right, that's mean root right, @IB. Okay. Now if I click that, is it this some IP? No, this is the different IP. Sorry. SSH I colon E PEM @ IP. I have copied the IP. Okay, sorry. It is creating the SSH file. Okay. page encryptions. Now you are in that server. Let it be clear. You are in the server itself. I have changed the server name in some admin, right? Okay, now if you check that, host -I, and find out this is the IP. Okay, that is 173, right? Let's go to what is the IP. This is the private IP. Okay, actually this is my private IP, and I'm accessing these applications via public IP. Now you can do all the activity, like you can install C, you can download the C compiler, you can download the Java compiler. There are a lot of commands in the possible, right? If you want, I can show you some of the cases. Say it is a chat GPT, yeah? Give me Linux user creation command with home path, user name, install, home path is as home as install. Install under sudo. What I asked that give me the Linux command. Give me the Linux command. I know that we know that people are know Linux very well, but suppose we don't know the Linux, right? We know that not only Linux, any command. Okay, so you just specify, try to utilize that feature. Okay, what is saying that it's asking to create that sudo add user some install, right? If you executing this command directly here, it will create the user. So install user is being created. SU I have not created the password yet. I have not created the password. Set the password. Just mention set the password of install user. I know that the command is password install, right? But suppose you don't know that how to utilize these things. Sudo password install, right? Just copy. Execute. This is asking for the password. The password has been changed successfully, right? Now I am going to that install user. Install. Now I'm in install user. You check that ID is install user, right? Now pwd, you see that path this. I don't know Linux, okay? I forgot the Linux. Maybe I forgot the command. I use ChatGPT. So you can use ChatGPT, but it's not part of this discussion, but it's a very useful tool. Anything, if you explain it very well, then it will give you that hints how to proceed with that ChatGPT steps. Okay, let me go to that one part. Now, what happened? I told you that in AWS, that EC2 instance, I have to create manual, but there is a concept of Terraform. Okay, you may heard about that. Terraform is that infrastructure as code. is helping us to create the infrastructure manually with some code quickly, right? So what happened? I'm just going to that GCP console. This is I have created for you guys already, such that it will be very fast forward. I'm connecting to the cloud cell of GCP. Okay, it is a cloud cell in that GCP site. You can log in and you can just click this button, right? You in the right hand side, this is the cloud cell button. I know everyone knows some of that class who are in this session. They know how to hit that. And if I go to this cloud cell, I have some. Okay, you may not able to see here. I just opened the editor here. Sorry, it's slow. Yes, this is the editor. Okay. Now in editor I have written some Terraform script. Okay, what is this Terraform script? It is a automation script which will create your infrastructure very fast. And why I am showing this thing is very useful tool. I think it can be implemented for students who want to learn some that cloud. They can start with the Terraform and basic console point of sight. So what will happen is, if you see in this particular cloud in VM instance, I show you that there is no virtual machine, right? No virtual machine. Okay, no virtual machine is there, right? So what I am doing, this particular Terraform script, I have written where actually this entire Terraform script will create some VMs, okay, virtual machines. Okay, if you see that there is a written code is there. So one is that my instance being created, okay, and with the image like that. It's not a very simple code, okay, and you can ask it from that Terraform. So some code, some another instance is mentioned, installation space I'm going to create, okay, and it will create some subnets also. That is public and private subnets. Okay, how this private subnets being using that, we have some JSON key. Just have to be downloaded from that. How to download the JSON key? I don't have time to download these things. You can go through Google, you can find out, and you can connect me offline. I am available on the LinkedIn always. You can connect me offline also. I can guide you if you want to learn about the Terraform. It's my favorite area because that's why I'm trying to show you. So this is that automated script. It's a very simple code. It actually create some subnets, and within the subnet that will create some virtual machine. Okay. Now I don't have any virtual machine here. Now if we go to that, every time to create the virtual machine, we have to go in the console. We have to select the region. We have to create the virtual region. So what I have done, little bit modernization. What we have done, there is a variable terraform.tf variable. What I mentioned, if you see here, this region I'm creating the Europe.os in region. I'm creating a one VMs. In zone, I'm creating that in particular OS1 we have a zone B. In that zone B, I'm going to create that instances. Suppose if you want to change the region, you can just provide the region ID for GCP. You can find it from the Google console itself. In that region, you will create and you will just execute some command. It will be automatically creating this script. Let's go to that path. Okay. CD. Where is my code? Paste here. Plus minus LRT. You see the same codes are there. What are the steps? Terraform init. It will create the background that does services which is required to execute this thing. Now you have to validate the code. Success. So that's mean my Terraform code is also, if there any wrong in that code, they will highlight this code. Okay. Terraform apply. That will create that my infrastructure. Okay, spelling mistake. If you see that is started creating, what is I saying that it's create a plan. It's asking that 6 objects to be created. Okay, and do you want to continue or not? What is actually trying to create? This is mentioned here, but I'm not going to see that. Let's see how being created. Let me say yes. Now you see, both to that, it's been creating subnet, creating. Where the subnet being creating? They are creating the subnet in West Europe West region, that is London region. Okay. If I just change that value to the different region, automatically it will create to that region. See, look, the subnet's been created. Let's wait for 1 or 2 minutes. I think this all object will be created. Still subnet being created. There are some error in invalid field. I think that is passed. Let me check the completion. Okay, if you see that the VM being created, creation is completed. VM being created, completion. So let's go to that site. Do you have VMs here or not? Let me refresh these things. Look, 2 VMs are being created, and these has no public IPs. All private subnet VM we have created. Okay, so that's mean you see that if you are, I know that if you are do via console, it will take a lot of time. Creation of subnet, creation of VPC, creation of subnet, creation of internal logic, creation of VMs. Okay, now if you go to the VMs, you can go directly VMs. Okay, go to the SSH. Look, the region is Europe OSB, right? See, the region is Europe OSB. Now I'm connecting these things, this server. You don't have permission to access this application and this server from outside this network. So that's mean you have to connect it from the console itself, or you have to use the jump host. That is different concept of designing, which actually we are opening this instance from GCP console. That's why it is sending the SSH key to this file from GCP console. It is giving the authorization. Okay, can I connect this server from GCP? Because you are in GCP network, not in your laptop network. Now you are in that path. Okay, this is the server which we have using. Okay, now you can download, you can do all that activity, but it is a private subnet. It has no connectivity to the internet. Okay, you are not able to connect it there. If I say ping google.com, not able to ping. But if you go to that server, ping gold.com, it's able to ping. Why it is able to ping? Because it is in public subnet. Why it is not able to do that? Because it is in private subnet. Now, how it is able to do that? There is some security way. CloudNet, it is there. You can give the CloudNet permission to outgoing traffic. So this is a big part which we can go through later on. But now, if you see, this is the infrastructure we have created, right? This is the infrastructure we have created in couple of minutes, within 1 or 2 minutes. But we don't need this infrastructure. Okay, let's destroy the infrastructure. Terraform, simple English language. Terraform destroy. It's destroying entire infrastructure. You want to destroy? Yes. So these are destroying. Let it be destroyed by the time. I told you that it's a why this automation is helping to build database. I mentioned the Europe West 1, right? Let it be Europe West 2. That is different region. Okay, maybe I think it is Germany. Go Google it. Google cloud regions name. US East 1, Asia, this is Mumbai. Let it be copy this one. Okay. Let's ping. Now you want to create. Is it done? Okay. Go to that terminal again. It is destroyed. Still destroying. It's destroying. 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 Still destroying. You see, this is the Europe West 1, right? Now I modify these things. Just simply modify only one parameter. Asia East 1, but in that which region I have to mention? In region we have zone, right? London has 3 zones, and Asia, I think Asia has how many zones? I checked that, right? Exactly. Okay. If you see, zone, it has 3 zones. South Asia B, Asia B, South Asia. 3 zones are there. Okay. So in that particular, I'm creating the zone B. What I have modified? Let's go to that my script. I just modified this zone. Now check that here. I think by the time already it's been all the released. Okay. It's been destroyed. It's already completed. Okay. Look, there's no instance. Okay. All are deleted. Now I saved it. Save all. Now let's go to the terminal again and execute same commands. Clear the screen. Terraform init, enabling provider, Terraform validate, Terraform apply. Now it's been created. Yes. Creating the subnet. These all subnet were deleted already. I have deleted that earlier comment. You see this being service being created in that region, Asia South region routers. Okay. So what I am to tell that to start that cloud journey for the students, I think better you can start from the basic networking and ask them to install the virtual machines and services using Terraform. Then write that all that college assignment, whatever way they are writing for C, C++, Java, implement these things in that virtual machine. Some errors. Routers. Okay, fine. What result? Zones. What they doesn't have enough resources. This means that my account doesn't have that actions to create the resources in this zone. Okay, and what is that? Another reason is virtual instance currently unable in the Asia. So that's mean I have used that this type of virtual machine in one standard virtual machine. Okay, these virtual machines images are not available in Asia zone, so that's why I'm not able to create. It's available in Europe zone. That's why I'm able to create. So thing is that we need to check that all the images which we are using, this is available or on that particular region or not. If it is available, it can be created. So instead of creating here, but if you see that at least this being created. Okay, so if I go here, no objects being created, right? But if I go to VPC network, you see there are one VPC network being created, right? Which we have written in my code. Okay. There are two one private, one public VPC being created. Then internal IP ranges is being mentioned. This is the gateway. Okay, but we are not able to create that virtual machine because I don't have any images in that region. Okay, let me check what are the images are available in that region. Okay, I can select that region. Compute. very slow. Sorry. Compute engines. Okay, let me create manually. If I want to create, I can see that the images from here in that region. Okay, instance 1, I'm choosing the SCS specific, right? It's too slow, man. It's my network problem. Asia Southeast one, right? No, Southeast. What we have taken. South 1B, Asia South 1, right? Asia South, not Southeast. Mumbai region we have to consider. Okay, this is Mumbai region we have considered, right? If I go to the zone.
Mr. Shotler, just interrupting. Participants are requesting to zoom the screen because they are not able to.
Just hold on.
And there are some questions actually which I have posted.
Sure. Yeah, sure. Let me do that. How to zoom it?
Probably you could use a magnifier, screen magnifier, or any other app.
This is that options is there. It can be increased settings. Okay, so sorry, I am not able to increase that. Okay, so it's very slow. It's my network problem. Okay, now what will happen if we find out the instance details here? You can image name and you can go and modify that particular image which we have used in the Terraform. So that automation we can use, and if you want, I can pass you the script later on offline. Okay. So I think it's already 1 o'clock, and we can have some question answers. So how can I check the question answers? Sorry.
I have already posted the questions on the chat box because majority of our participants are on the YouTube, and the program is actually live streamed on our YouTube channel.
Okay.
So I am copying the questions.
Okay.
And pasting it on the chat box here.
Okay. Where is that? Where is my YouTube joining session? I forgot that. Okay, this one, right? Where is my chat box? I joined from here, right? Yeah, this one. Okay, what's the questions?
Questions are on the chat, yeah.
Yeah. Okay. First question. Are there any option other than the Active Directory for authorization and authentication? Yes, we have a lot of market available tools. Even AWS have their authority tool, that Cognito services, which being used for that authorizations for that. Active Directory is very much popular because most of the organization being already attached with that on-prem Active Directory, so that's why it's now being more secure. That's why most of the organization using that Active Directory. But there are a lot of freewares available. If you can search that open authentication services, that it is SAML services. You can find out the SAML services. There are a lot of services that are available, but On AWS side, I know that Cognito is the one of the services which can be used in place of Active Directory. Kindly give some the practical idea of S3 instance using AWS. Okay, that's a very good question. Good things. Okay, now S3. What is S3? S3 is a service bucket where you can upload anything where that application can a huge number of storage we can store. Okay, and in AWS we have different type of storage capabilities. One is EBS solution, EFS solution, and S3. S3 mostly which we are using whenever it's being accessed for a global purpose, and we have some specific data which we want to store for further processing, not real-time processing. For example, one of the application which where we are gathering analytics applications, actually we are gathering the service data from multi-stream, multi-other application. What they are thinking, because we have publicly exposed this S3 bucket to the internet with some authentication. So what happened? Other application, they are uploading or accessing this S3 bucket and uploading this first to that S3 bucket, and whenever our job need to be executed, that S3 bucket data would be accessed by our application and it can be used. Okay? But S3 bucket is mostly using that storing the data which been coming from that other applications for further processing, or if you want to store the backup. For example, we have some online processing, our application is running daily basis and we are creating a lot of logs in our application log, right? And logs being created daily basis, and it's huge logs being created. So what we are doing, we are moving these logs to that every 7 days data to S3 bucket. There are different type of S3 buckets because frequently used S3 buckets. There are Glacier is there. There is a cold S3 bucket is there. That the logs which we need to access yearly once, we can pass to that that type of storage. If it is being frequently used weekly once, we can keep the S3 bucket, but not in EFS because EFS is highly costly. So mostly we are being using that log sitting. We are keeping into that S3 bucket or some the data, huge data which is coming from the other states. Next question. Is there any free cloud server where we can create resources, create instances and deploy for our application? Yes. Now, I don't get the question, but if you want to learn something, if you are do the testing, I think you can do that for AWS because free subscription is there for 1 year in AWS, and GCP is 3 months, Azure also 3 months. Where you can host your application and execute it. But completely free, I don't know. It's really available or not. Where you can host your application totally. We need to dig out, but it's not right because if you are hosting your application, it's running for your business purpose, and you want everything to be free. It should not be possible. But for training purpose, you can use AWS Cloud or GCP and Azure. These are the free popular cloud provider where you can use for your free services. What is there any free cloud server where we can create resource? Same question. Anything else, sir? Anyone?
No, I think there are no more questions from the participants' end. So far, I can find it on the YouTube.
Okay, fine. That's fine, sir. I think it's very late participants from that college itself also. It's fine. Okay, so what will happen? So if you want to if you want to get more information, you can connect me on the LinkedIn profile. And cloud is huge. There is a lot of things we are learning daily basis, which we may not be available nowadays. I might not be aware, but I will try to find out. But mostly the cloud is whenever we are providing the solutioning part, we need to consider about that security point of sight. Okay, So if I not able to give you some answer on that chat itself today or whenever we are connecting on the LinkedIn, I will try to dig out and find out and provide the answer. But cloud is very vast, very vast. Every solutions being challenging to implement these things because security is high, and truly speaking, to implementation the same things, it's time consuming. But now main focus whenever we are implementing from the cloud is that using cloud console, but that time consuming. That's why most of the time either using Terraform or that is for infrastructure provisioning point of sight. And if you have a Kubernetes, then you can use that deployment purpose. There are different deployment processes there, but it's very complex. I have not gone through that Kubernetes class because it's very complex. Even I'm learning daily basis also, and it's very challenging and very complex. And Kubernetes, we don't have any console things. Everything need to be done from that Linux mob. So if you don't have anything, then shall we close or can we?
So thank you, sir. So on the behalf of the organizing committee, I convey my deep regards and hearty thanks to our speaker, Mr. Shubhro Sharkar, Principal Consultant, Tech Mahindra, for providing a practical exposure. Hands-on was very nice. Exposure on effective smart systems, tools, and applications related to cloud migration and automation. And sir, I would like to present you a token of appreciation certificate, which I'll be sharing it here.
Thank you.
And I think we have already mailed you the certificate and honorarium. So, sir, please acknowledge it and please revert to us whether you have received it or not.
Okay, thank you, sir.
So,
thank you. Thank you.
So I'll be presenting the certificate, sir, right now.
Stop sharing my point.
Yeah. So, is it visible?
No.
I think it's coming. I think it's the network is slow.
Yeah, it's fine. Thank you. I can see that. Thank you very much, sir.
So that's all from our end, and we close the session here. And thank you once again, Mr. Sharkar, for that very informative talk and the hands-on that you have provided on cloud migration and automation. Thank you. So we close the session over here, and we join tomorrow again at 3 p.m.
Thank you, sir.
Thank you.